Yo, what's up, everybody? Welcome back. Today we are working on making a procedural cartoon vacuum hose. And the context for this thing is that we want to work on making a chamber for our collaborative Rube Goldberg machine. So what you're seeing here is this machine where balls are moving between different chambers, we're calling them, and each chamber is completely custom defined by a WebAssembly module. So the idea is that because they're WebAssembly, people can compile and upload their own, and then we can just add, random simulations to our list of the total thing, right? And so what I want to do is I want to make one today where the vision is we have like a vacuum cleaner, and the vacuum cleaner kind of rolls around the chamber and tries to pick up balls and put them in like his little canister, and every once in a while like empty the canister somewhere, right? And so to do that, we're gonna have like a hose coming out, and he's going to kind of like walk up to a ball and then kind of like like suck him in, and the ball's gonna like shoot in here, right? Now the interesting part of this is definitely the hose. So how do we like render something like that? And so I'm kind of thinking, you can kind of use like a Bezier curve with like 4 points. So yesterday we actually built this Bezier curve editor thing. It's pretty rudimentary, but it's probably good enough. And so the vision is that with this kind of control here, we can say that the top left of this curve is attached to the vacuum hose, and kind of like the amount that this is pulling out right is kind of like how stiff the hose is at the beginning of the vacuum, or at the beginning of it, right? Because like when you have a hose and it's like clamped into the edge, there's usually some stiffness around the edge, and then it starts having like more flexibility the farther you get out from it. The second part of this curve is going to represent kind of like how stiff the end of the hose is, right? Like usually your the vacuum hose kind of like it comes out of the vacuum and it's kind of stiff here, right? Then it kind of like wiggles around, and then at the end, like what I've seen is like kind of like a little plastic knob here that's like really fixed, and so you have some sort of stiffness at the end as well. And so this kind of represents the stiffness. And so I want to make some sort of control where this section kind of automatically points towards whatever we're trying to pick up, and we can figure it out from there. So we have the ability now to draw a Bezier curve, great, but we only are rendering this as like line segments. What I want to render is kind of more like some sort of textured rectangle, right? So you can imagine if you look up like, I don't know, cartoon vacuum hose. These like hoses are kind of like accordioned a little bit. Here's like, right? So like there's like these like markings that you see that where they can stretch down, kind of like a slinky, right? And we can approximate those as just kind of like lines on this thing. And so we have to figure out how the fuck are we going to draw these lines. And so my thought is that you can say that your curve is very similar to a rectangle, right? Not like maybe perfectly similar to a rectangle, but you could think of it as kind of like along the curve is your x-axis, and kind of how far you are from the center is your y-axis. And then what we can do is we can like draw some sort of texture where we just draw vertical lines on here, and then we just need to have some way to map this onto this thing, right? And so the question becomes, one, how do we make like a rectangle coordinate system around a Bezier curve? So we're gonna have to figure that out, and then we're gonna have to figure out how do we like sample from another image, or maybe we don't have to sample. Maybe we can do like a procedural generated texture. That's also possible, right? We could make some sort of object that takes in an x and y position, and that object could choose to sample from an image, or it could just like calculate sine x and draw lines that way, something like that. So I think that the plan is probably start by drawing a textured rectangle. Our rendering library that we have right now, we haven't implemented like draw a box yet. And so I think that as part of our task to make a vacuum, we're going to have to like have some sort of like texture of the vacuum itself that we pull in. I drew one off stream yesterday, a really shitty version of it. Let's see if it's like around somewhere. It would have been called vacuum PNG. So, man, it looks so shit. But I think that we probably want to like pull this thing out, render this, then we'll have like the ability to like texture map onto a rectangle. Then it'll be easy to combine that with the idea of making a Bezier curve have rectangle coordinate system, and then we'll be able to do the second half as well. You can probably use the Pong logic to make the vacuum automatically reach out to the nearest ball. Yeah, I think that I'm probably we can experiment with it by having it trace the mouse in our like little test area first. So I think that's probably what we're gonna do. Anyways, okay. So I think that's enough for intro. That's enough for intro. Let's start by trying to draw a textured rectangle, which I think should be relatively straightforward. I think this is probably going to be like the easiest thing ever. Okay, so we have this graphics zig thing, and let's just kind of say we have a function, and we're going to call it render rect. And this is going to take in a position of the rectangle. Maybe we'll call this like center. And then we'll have width and height. I have not been really digging these APIs that we're making that have like whatever this is, like 1, 2, 3, 4, 5, 6 function or 6 arguments. So I think what I want to do is I want to make like a like chamber or canvas, and this canvas can have, we can give it the inner like data, which is a bunch of U32s. Each pixel is 4 bytes, so we represent them as U32. And we can also just give it its width here. And now we can say that we have a height can be calculated from the data and the width, right? So it's just be data len over width, like this. And then we can just pass in a canvas here instead, which should be nicer to work with. So this is what, how do you do this again? You say self is a canvas. There we go. And this is self.width. Okay, so now this takes in a center, width, and height, and a canvas. And man, is that nicer. Const canvas, whatever, doesn't matter. It doesn't matter. Probably const canvas. Okay. So, how do we render a rectangle? The reason I'm deciding to put it as center, width, height instead of top left, bottom right is because I want it to extend to rotated rectangles really easily later. And actually, I kind of like the idea here of having a rectangle as well, to be honest. That makes this feel much simpler. So we have a center, so pause 2, and width is a F32, and height is F32. Cool. So now we can just take in a rect. Boom, 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 rect. Cool. Okay, so what's this going to do? It's going to say for y, we're going to have to do like normalized to pixel space conversions. So let's kind of just say y to y pix, and we'll take in a y normalized position here as a float, and self as a const canvas. Boom. He will return a u size I64. I guess having negative pixel positions makes sense in some contexts, probably. And this will just call our like return to ypx info that we've already have, but just with y norm and the other parameters filled in automatically. So width and self height. And then we have 2xpix as well. Takes in x norm. Takes in 2xpix impl with x norm and self width. There we go. Chillin'. So now we can say that our x start is equal to rect center x minus width over 2.0. So I call this half width is rect width over 2. Yup. So this is going to be minus half width, and this is going to be converted to an x pixel. Hello, canvas to x pix. Boom. And then the x end is plus half width. Then our y is the same thing, but with y. Like this, to y to y. y and y, and this is half height instead. Half height. Boom. Boom, 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 boom. Okay. Now it's easy. For, I guess we have to clamp these, so, and we have to iterate, these are I64s, which you can't iterate with for loops in Zig, so we start with var y is equal to y start. While true, if y is greater than or equal to y end, we break. And then we say defer y plus equals 1. And then we do our stuff, so. My brain's melting. We're doing an X iteration now, I guess. Same problem. Are we guaranteed that y starts smaller on start than end? Yes, and X also guaranteed to be... I think these have to be inverted, actually, because our y pixels have positive normalized spaces up and smaller pixel spaces up. So we have to invert those, which is fine. Not the end of the world. Okay, so var x equals x start, while true, do the same thing. If x is greater than or equal to x end, we break, defer x plus equals 1, and then we can just write the canvas. So, what does it matter about here? Oh, I mistyped this. Cool. Okay, so here's just canvas data at y. Oh, here we need to convert to u sizes. So, oh, here we also have to like guard. So if y is less than 0 or y is greater than or equal to canvas dot height. Should we cache canvas height? Probably. It feels like we should. I don't know if it's like fucking silly to do this, but it's fine. Canvas height. We continue. We need to make sure that we do this after defer, or else we will just infinite loop in that case. And here we have the same problem, but with width. Cool, 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 cool. Canvas width. Now we can say const here. I guess we have a y usize is a usize of int cast y. And we have the same thing here with x, where we cast two usize to use in an array. We can say y times canvas width plus x. And right now we'll just assign that to like black. We'll make it black. Okay. Cool. So now we should be able to go into our little like sample area where we're playing around, which is in index.zig, and let's just like try to render a rectangle. Graphics, render rect. So here we are going to define a rectangle, which comes from graphics rectangle, and this is going to be like width 0.1, height 0.2, center at 0.5, 0.5. Cool. And then we have our new like canvas concept. So we'll call this like graphics canvas. Is a graphics canvas who has a width of canvas width. I think we've got that defined somewhere. Yep. And data is equal to and canvas memory. Maybe it's, yeah, ampersand. Cool. Now passing the rect and the graphics canvas. And we should be chilling. Like it's build exe. Not like this. We don't use stack size change, and this is called index zig. He doesn't like this because I didn't put an ampersand on this. Needs to be pointer. Okay. So now we should be able to go into our little test thing. And we have a little black rectangle here, which is good. It's hard to see there because the background's gray, but we do have that. Okay, so now what I want to do is I want to add, does the canvas not have a height as well? It's inferred from the data length. It's inferred. So the data is like some number of bytes, and the height is the number of, or the number of elements divided by the width. Okay, so now we should be able to like turn this thing into something that like samples from something. And so I don't think I want to be just like put in a like image or a color. What I really want to do is I want to put in some form of like texturer. Texturer. I feel like there's like an E missing in there, but maybe it's fine. And what I think I want to do is I want to have like some sort of like compile time resolved object that can do custom behavior. Yeah. And I'm hoping that the compiler is smart enough that if I just say like texture return xff, that will compile into something sane. I don't know that it will, but I'm hoping it will. So here we can say texture get color. Well, maybe just call it texture.get. And we can pass in what I would like to pass in like the normalized coordinates here, which I guess means that we have to do an extra calculation, which is maybe fine. It's probably fine. So here we'll do something like because it'd be nice if this could work in normalized space. Or we could pass in maybe like x and y as well as like their bounds, because then we don't have to take the calculation cost of these things if we don't want to. So we could pass in like x start, y start. Arguably, that's a little silly because, like, yeah, that's a little silly because having to do this for every pixel where you like calculate the normalized coordinates doesn't really make sense to me. Yeah, fuck it. Fuck it. We'll just do here. Const y dist is yn minus y start. We'll do the same for x. Right? And then here, we will pass in const x norm is going to be the x minus x start as a float. And then we divide that by the distance. And we do the same thing for y. And we pass it to the texture. And I hope that this isn't too expensive, but we'll find out. We'll definitely find out. And if it turns out that it's a problem, we can always fix it later. Okay. Cool. So now we have to make this object. So let's just start by making a shitty little texturer. And he's gonna have a function get, and who's gonna return a U32. And he's gonna take in self is a const texturer, and an x, and a y. And he is gonna say fuck x, fuck y, fuck self, return blue. And then we will make our texture. I think we can probably pass it in by value. He's mad. Fucking asshole. He hates us. Float from int like this. I guess we shouldn't cast a float from int here. We should actually do f32 like this. Up here, we only have to do this conversion one time. Although the compiler probably would have figured it out. Okay, so he doesn't like get not being marked public. He's a little whiner, this guy. Okay, so this is now... Oh, I made it green instead of blue by mistake. I did want to make it blue. Oopsies, that's not blue either. That should be blue? Okay, cool. So that concept seems to work, at least in this regard. And now, can we do something like try to do a gradient? So we can make like the top left red, bottom right green. How do they do this usually? Yeah, you just set the x coordinate and y coordinate to be two of the different axes here. So we can just say return x times 255. Yes, this is const r. And we'll say g is y times 255. These should be u8s. So then we will kind of like float from int these. Or int from float. Oh, hey, I love Beziers. I passed a Bezier curve course once and it was great on a curve. Good one. Good one. And then here we will return alpha full plus r plus g shifted left by 8. So maybe we should make this a u16 for g. Otherwise, it won't like that. And that should give us something a little interesting. I guess we can just make them all u32s, and then that makes it simpler. Didn't work. Did not work. So, why? Why? I would have expected this to be black in the corner. That's what I've expected. So I fucked something up. So if we do this, that's black. That makes sense to me. Now, if we say x times 255 is equal to r, okay, well that red gradient is working. That seems reasonable to me. So it was the g one that wasn't working. Oh, I probably had it the order of operations wrong. It's probably like this. Oh yeah, there we go. Sick. Okay, so that's pretty clear that we can kind of like texture this rectangle now however we want. And now let's kind of like use our vacuum here. Let's stick our vacuum into the thing. So this is vacuum.png. I probably want to scale this down a little bit, to be honest. Like, we probably want this to be maybe like a 20 by 10 thing. It's 300 bytes or something. So can we like open this with like GIMP and just... Does GIMP open SVGs? Yeah, it looks like it does. And then can we like image transform? Scale image. We do like maybe 200, 150. So what is that? Kcalc 150 times 300 or times 150 times 100. Shut up. Shut up. 150 times 100. What the fuck is going on? 150 times 100. 15k. That's a little silly. That feels way too big. If we're just storing it uncompressed. What if we do like 50? 50 by 34. 1.7k, that feels way more reasonable. And is it like... That's like good enough for now. I'm not really too worried about it. Okay, let's do that. Now we have to somehow get this as like uncompressed, just like raw RGB. Or we have to like encode, we have to like add like a fucking PNG decoder to our wasm module. Which maybe is fine. I wonder how big that is. I'm kind of curious. I'm curious. If we pull an STB image and just try to decode like a PNG, I wonder how unreasonable that is. I'm very curious too. So if we do right now, we don't pull anything in. Right? So our index wasm is 3.2k. Okay? Let's keep that in mind. Keep that in our heads. Curl-o stb this thing. And can we just kind of want to like make this thing, but with as few options as possible. So we kind of want like all of these, but except for PNG. Can we, oh, only PNG. This is what we want. Define STBI only PNG. Okay. Sure. So I think we have to do like stb image.c, and we just say include stb image h, but we define stbi implementation as well as a, what was it? stbi only PNG. Oh, stb image implementation. Sorry. And then the other thing was only PNG. STBI was like that. Okay. So then in our index zig, which we already have open, we should be able to do like const c is equal to import c import, like this I think it's called, and it's like a c include stb image h. We should be able to build exe, and we include stb image.c and -i dot. He doesn't like that because there's stdio.h and stb image. Can we get rid of that? stbi, no stdio. Okay, cool. And we probably have to declare, we probably have to find these in both places, which is going to be a little annoying. Was it stbi? Yeah, it was. No stdlib. What do they use this for? It's not clear. I guess we can just delete it and see what fucking happens. String.h as well. We just delete these, what happens? Math.h? Fuck. That's not good. That's not good. Because I don't think that we can do like LC here to fix that. Oh, we can. That's surprising to me. That's actually really surprising. So I guess maybe they only need like includes from there and no actual libc symbols, and so it's like maybe fine. Interesting. Or maybe it's like because we're not using it's not getting compiled in. That's also possible. So I wonder what happens if we try to like decode a PNG. So let's do this. To test this, we can do pub. I guess we embed a PNG. Include embed file. We will embed vacuum PNG, which means we have to copy vacuum PNG here. Okay. Zig build exe. Okay. First of all, how big is our thing? ls-l. We have increased in size. We are still 3K. So it's likely that this stuff just isn't getting called. That's how I feel right now. So let's kind of see how it looks like. If we were to try to load from memory. And how the fuck does this work? We load from some buffer and it returns a new buffer. I mean, surely we need to give it an allocator as well, right? Define stbi malloc, stbi reoc, and stbi free. Yeah, that makes sense. Unless Zig is going to do this for us. I guess we'll find out. We'll find out. Okay, so was it from memory? Load from memory, buffer length, XY. So channels, okay. I think there's a good chance this just doesn't like work easily, and we might degrade to just sticking the bytes of our image in here, but I'm curious. So PNG dot, I guess this is and PNG len X, Y, desired channels 1, I don't know. Var X is I32 is undefined. And Y is also an undefined Y32. And like surely this is compile, right? Load from memory requires an extra argument. What was it? Load from memory. Buffer length int y channels. Ah. Can I just write like channels here? I guess fine. Bar channels either choose undefined. Okay. Okay. Does that compile? Expected type that, found that, so I guess this is not ampersand. Value of type this ignored, so const val is equal to this. And then we discard it. Yeah, okay. So, oh, that's actually not too bad. So it's just malloc, free, and realloc, and we can just define those into using our wasm allocator. That's actually not that bad at all. That's we can make that work. We can make that work. Pub export function malloc. What is the API of malloc again? It's just a size. So size, usize returns a void, and we just wasm wasm alloc. Do we not stood keep wasm allocator alloc? And I guess we just allocate a size. Maybe we should do like 4-byte alignment just in case. I think it's probably fine, but it's probably worth making sure we get that right. So it's optional alignment. We'll just write that as 4 and then null. So 4 null like this. And I guess we'll just kind of do some like link time typecasting. So this or else or catch unreachable. And this returns alloc with options payload, which I assume is just going to be like U8 like this. Maybe. Oh, fuck. But free is going to be fucked. Catch and return null. Oh, that makes sense as well. This is fucked, though, because we need to record the size for free to work. Right? When we call free... yeah, for the free API requires, like, a slice. Which fucking sucks. Ooh, how do I want to handle this? I mean, we could do like struct, you know, pointers. This really, I don't know how much I like this. Var pointers is a struct. I guess it's just kind of like a hash map from U8 pointer to usize. Perfect. And then here we will just say const ret is this thing. Catch return null. You can allocate size plus 4 and then put the thing before the thing. Yeah, I do like that better. You're right. That's a pretty good, a good fix. I do like that. I do like that. So here we can do ret 0 to 4 is equal to a stood mem as bytes of size. Invalid left hand of assignment. Really? Oh, is it mem copy like this? And then we return ret 4 onwards pointer. Yeah. Okay, so for free, we take in our pointer, which we're gonna view as a U8 slice. We are going to maybe say pointer minus 4 is the actual pointer. And then we say actual pointer 0 to 4 is the slang. So we'll say const len is a use size. Comes from stud mem bytes as value of a use size like this. And then we stud heap wasm allocator free actual pointer 0 to len. And here we want to say actual len is what we want to store here. Yep. This is for wasm's use as 4 bytes, right? Yep, that's my understanding. That is my understanding. And then we just need realloc as well. Well, we'll see so far what is broken. So here, these guys, this malloc needs to return an optional. Things it might not work. This doesn't like this, so we can just say like align cast here. Was that what they wanted? Align cast must have a known type. That's annoying. Maybe it's easier to do this. We copy to stud mem as bytes of len from the actual pointer 0 to 4. Then we don't have to worry about like alignment issues and stuff. Count mem copy to a constant pointer, so this will be variable, that's fine. And now we're just missing realloc. I wonder if we can like, can we disable realloc so I don't have to think about it? No. Okay. So how does realloc work? It's like we allocate a thing of the new size and change the size of the memory block pointed by pointer to size bytes. The contents of the memory will be unchanged in the range from the start of the region up to the minimum of the old and new sizes. If the new size is larger than the old size, then the added memory will not be initialized. If pointer is null, then the call equivalent to malloc size for all values of size. If size is equal to 0 and pointer is not null, then the call is equivalent to free. Unless pointer is null, then it may be returned by something blah 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 blah. Change the size of the memory block pointed to. So it doesn't return a new pointer. It actually uses the same fucking virtual memory address. Is that how this works? Just put unreachable in realloc. I like the way you think. So this is no returns new if needed. It's just weird because it said changes, not like allocates a new thing and copies it in. If it can resize and place it, returns the same pointer. Oh, it's so confusing. I get it. Okay. But I like the idea of just not doing it for now. So this returns a new U8 pointer. And I guess this is technically nullable as well. If your memory is not fragmented, you can resize place. That makes a lot of sense. Okay, so that compiles. It'd be interesting now to see. Okay, so we've loaded this image theoretically. I'm surprised that we made it this far, to be honest. And our texturer now is going to take in our like buffer of bytes. So we'll call this like image is a like bunch of U32s, right? No. Yeah, because we want RGBA. So we'll ask for 4. This is going to return a bunch of U32s. Now, what? We also need like the input width and height. And now our texture is basically just going to take the value from the image at that width and height. So XU is going to be a U size int from float of x times self width. And we need like a const width f is a f32 float from int of self width. Height f. I guess it kind of makes sense to store these as floats then, huh? Even though it's a little silly, it makes more sense for these calculations. Like this, and then we just say image at x, u, y, u. I guess we can store width u as well. This needs to be here as well. So say width u and width f, yu times self width u plus x u. There. There's like a chance that works. This needs to be self width f. And now we just construct this thing. So texture, when we make this thing, we're going to take this from the fucking load from image. So this has to be done externally. This is stupid to do here. I guess we'll just do it on the first iteration. That makes sense to me. So here we're going to have like a global variable that's like a decoded PNG is a possible U32 array. Okay, so we'll say here, if val is equal to null, we are going to make val equal to, or not val, decoded PNG. And then I guess we'll have like PNG width. I guess we'll just make the texture. Texturer is a optional texture. Yeah. If texture is null, then we can load the thing from memory. We need to maybe say texturer is equal to image is a pointer cast of image data. And we probably have to align cast this thing as well. And then where the fuck is the definition of texture? Hello? Oh, there. Width u, width f, and height. So this kind of goes like this. Width u is an int cast of this. Width f is a float from int of that. And height is an int cast of y. There's like a non-zero chance this works, but a much higher chance it just fucking crashes. Illegal pointer cast to slice. Really? What does stbi load from memory return? Returns unsigned character array. So how is this not okay? Oh, because it doesn't know the length. We need to go from 0 to x times y. So this is x times y as int cast. That would do it. That would do it. So this is like this. I guess maybe we'll do this times 4, 0 to len. Then we'll pointer cast the slice like that. That feels like it makes sense. Feels like it makes sense. Implement pointer cast between slices, changing the length. Okay. Data u8 is image data 0 to len. Then here, can I do data u8? Is that fine? No. How am I supposed to cast between like a u8 array to a different way? It's like stood mem like as bytes as slice. That feels right. So here, then we can just do data u32, I guess. Hopefully. And then we can align cast it. Get that shit out of the way. Expected integer vector found something else, 177. So int cast y. Oh, this is a float from int. probably. We wanted height as a float. Close. No field remember get in index texture. So here we need to basically just dereference the texture. We know it's valid at this point. All right. Let's see what the fuck happens. Crashes. That makes a lot of sense. It's not really surprising in the slightest, to be honest. Index out of bounds. Okay, so maybe we like do we have a print in here? Graphics, print, image, data is this. And I guess we log it as a pointer. Index out of bounds even before that. Did we build it? We did. Do we do a proper refresh with cache clearing? Yes. I don't really understand. Where is our like backtrace? The fuck? Why don't I have a backtrace here? That sucks. Oh, maybe because we're not actually paused there. Okay. I mean, we can just kind of start like, hello. Let's start here. Hello. Okay. So we make it here. It's possible that realloc implementation is like fucking us. Yep, it is. It is. So we actually have to implement this thing. So, I mean, we can just do it as first of all, do we have realloc? Oh, we do. Hell yeah, dude. Hell yeah. So here we're gonna pull out the old pointer. And then instead of freeing it, we are just going to realloc old pointer to size plus 4, right? Okay, okay. And or else return null. Now we need to make sure we update the size. So we're going to say mem copy into new pointer 0 to 4 const new size real. What's this? And we copy in new size real. Boom. Probably like this. And then we return new pointer from 4 onwards. It doesn't like this because here pointer could be null. We'll just say that it can't be null. Fuck you if you make it null. He still doesn't like this. Not really that much of a shocker, to be honest. Can we maybe print new pointer okay? I just want to see. It's not. Oh, we didn't build maybe. No, okay. Can we say realloc here? Realloc. Okay, so there is something going on in this shenanigans. So it's index out of bounds. So should it be actual pointer 0 to ..len plus floor? Actual pointer 0. No, because I think that the length we store the like full size. We store the plus 4 in here, but we do also. Oh yeah, this is alignment, actual len. Feels like it should be fine. Maybe we print out. We will print out here. Like graphics print allocated this. Right? let's just kind of see that, and then we can say we're trying to reallocate this thing and see if we like kind of figure out the same reallocating. This looks like an old pointer. So we're gonna hope that we kind of see some sort of like consistency between those things. Why is my malloc? So the malloc's actually never getting called. Maybe we'll write down what the realloc parameters are. Ah, I see. I see. Okay. So man realloc null. So if pointer is null, then this is equivalent to malloc size. Okay, sure. If pointer is equal to null, malloc size. Otherwise, we can just use pointer directly like this. All right. Okay, so this is better. We are still getting some issues somewhere. But it's not just like realloc hard crashing, which is good for us. But it would be interesting to know where that is happening. So now we can kind of see, we'll see if we're at least getting a image. Allocating image. We are probably not. We're probably fucking doing something stupid in here still. So we have allocating image, we do some stuff, and then we crash, which is unfortunate for us. Unfortunate for us indeed. Indeed. Okay. So I guess we just have to double check all this stuff. So here we will say that we allocated this thing. Here we're saying that we are freeing this thing. And we'll maybe say free called with right at the beginning of this, just so that we always know if we're entering code that we fucked up, or if we're just returning something really fucked. This is size. And then down here on realloc, we have realloc called with this, and we say we're allocating old pointer. So, okay. Oh, we do get a hello world 3 at the bottom here. Image data return null. Oh, okay. So we actually did manage to get out of that thing. It's just the image data is not valid for some fucking reason. So it's pretty crazy that we actually got to a fully decoded. Well, we got through the call to load from memory. Now the question becomes, what the fuck? Like why is this returning null? How big is the wasm module? That's a really good question. That was a question I had at the beginning. 30K? So pretty fucking big. Pretty fucking big. This is with release small. So that's a problem, right? That's a problem in that adding that much is way more than the data of the PNG uncompressed. Right? If we just taken the PNG and stuck it in here uncompressed, it would have been like 1K. So that's fucking annoying. That is annoying. I wonder if you can like, let's see if what was it, the Rust wasm size? I think there's like something here where they told us about some tool that we can use to inspect Twiggy. Have you seen this ability, the ability to add a panic handler and print the trace? I found an example. That sounds kind of cool. Oh, is it just pub function panic and that's it? Oh, that's interesting. That's pretty cool. I'll take a look at that at some point, but for now, I'll just continue to be frustrated and slowly, do whatever we were doing. Printf debugging. And we do twiggy top-n20 index wasm data. How big is vacuum.png? 10K? So that's probably where a lot of it's coming from. Did we not export a smaller version of this? We'll call this export as small vacuum PNG. CP small vacuum PNG to vacuum PNG. Okay. So this is now 1.8K. Index.wasm 23K. Okay, so we just lost a bunch. We still have, okay, now code is pretty large. This is 22K. Code is taking up 4K of that. Code 22. I wonder if like not running with, can we do like release small, but like without stripping debug info? Maybe we do release safe. Oh, but that assert fail is possible. There we go. Oh, sorry. So this is now fucking ginormous. But we can see that like 8K from stibby load from memory. And maybe that's kind of reasonable. Wasm opt from index wasm to opt wasm. And let's just failed opening. Oh, sorry. Opt wasm from index wasm. Oops. Oh. This may be an unsupported version of Door. Fuck. Can I just make it like... Can I make it just continue through that? I'm just trying to compare like the stripped and unstripped size. That's annoying. Yeah, okay. Fuck. That's annoying. Because I want to be able to see which functions by name are taking up all of the space. But I guess we can probably make it a good approximation here that we have 16K-ish just from these three functions. And that kind of lines up with like the increased size of our binary as a whole. But I wonder if there's like some options we can turn on in STB image that will like kind of reduce that. Because I saw PNG, like something about like making a PNG, create PNG image raw, which is like, why? Oh, this is maybe self decoding, which makes sense. I wonder if there's other like size decrease things that we can do here, or if we're just fucked. Oh, I guess I also wanted to try if and def, stubby image magic. That's fine. Yeah, okay. Does Zig support G-Dwarf version? Oh, to try to get WASM opt to work better? That's interesting. Interesting thought. Here's what I'm gonna do first though. Before I look into that, I'm gonna say release small, and then I'm gonna say WASM opt OS opt WASM from index WASM. Let's just kind of see if WASM opt is managing to shrink this thing by a lot. And it's not. So we can assume that these kind of big code blocks are from STB image. Was that STB image only ping? Yeah, we have STB image C here where we define only PNG implementation, no CDIO. So does WASM strip help? I don't think it will, but we can try. So let's do this on opt WASM. Yeah, it's the same because it's all code. It's all code at this point. But we could go back to release fast, then strip it, to see if the code size is approximately the same. So release fast is a lot bigger. 4360. So we have like one 8K and then a few 4Ks. We have like a few 4Ks here. So if we were to do, look at this again, unstripped, we have the 8Ks load from memory and then a few 4Ks where create image raw and do zlib. So that probably lines up with create image raw and do zlib or something like that. I'm not really seeing, I doubt we're like gonna get free major savings here. So I think that that's enough information for me to say, screw it. Let's just embed the image uncompressed. I don't think like taking on the cost of this like PNG decoder is like silly. Now, there's a chance though. There's a chance that a different image format is more friendly to code size. Right? Because PNGs need to pull in like all of zlib. What if like a BMP, a simpler format, still has some sort of like size savings? Like what happens if we like export this as a small vacuum dot boom? Oopsies, actually, let's turn on that run like encoding. That's important. Right, let's just go. Oh, that's not. Cancel it. Why is this RLE thing? Like, why does it exist if I can't click it? What the fuck? Okay. Okay, but let's say that we did write this as small vacuum .pnv. It's a teaser. Yeah, he's just trying to get me excited. So this small vacuum BMP goes up in size to 6 point, which is silly. This is all gray, so we could save this as grayscale. Can we convert, like in GIMP, convert to grayscale? So I think that GIMPs support low bit depth like that. I just want to like remove color information entirely. This is not what I want. They're like, hey, how do I make a grayscale image? I'm like, no, I want to fucking save this. Set some palette limit to 256. I guess we could also just try, we could try a couple image formats. What if we do like GIF? I think GIFs have some sort of like intelligent shit where they have the ability to like kind of like set a color palette by default and stuff, so. Oh yeah, that's really fucking small. Okay, let's try. I'm assuming that SDB image has a GIF thing, and maybe it's smaller in image size, in like a. Does look like they have it. If you want to go more esoteric, you could try QI. I mean, yeah, we don't really have much. We don't have much. What do you call it? Like many constraints here. I mean, probably picking one that makes sense to use, like a library here, would be nice. Okay, let's just try only GIF, only GIF. Which one is going to make people less mad? If I say GIF or GIF, I can never remember. And then in index zig, I want to embed the GIF version. It's pronounced GIF. You guys are all helping me. Yeah, all of you are extremely helpful. Alternate between them to make everyone mad. Perfect. So here we'll pull GIF to vacuum GIF. And let's ls-l again. We want release small, not fast. That's not bad. That's a lot fucking smaller. Like a lot smaller. And it is in here. So that's a pretty fucking big win. Now, I'm concerned a little bit that it didn't yeah, I'm okay with that. That feels fine. I want to make sure that we background our thing. Our canvas memory is set to gray. So I'm a little concerned that we lost the transparency info. Do we not have transparency in GIFs? That kind of blows. As animation, the forever. Yeah, maybe it doesn't. Okay, but at least we know that different decoding options or different encoding formats have a massive effect on the code size generated here. So we just have to pick one of these that kind of balances good compression and low code size. And I don't know what all these are. So I've heard of JPEGs. I've heard of a small thing called a JPEG. I've heard of it. Am I in the right fucking folder? No. I want to go to work, Bezier curve editor. And I want to save this as vacuum.jpg. I didn't really look closely there. We'll come back to it in a second. But I also just wanted to go stbimage.h and just kind of see how bad JPEGs are. Let's just take a little peek skis. So 24K, we grew a lot. And it is 8K code, 3K data. So that 8K of code, I want to go back actually to the, how much of that was code when we had it as only GIF? 3K. So the GIF wins by 4 or 5K right now. What about BMP? We have to build it, I guess. Undefined symbol abs. Oh, that's annoying. Oh, we can fix that though. That's fixable. If we just go into our index zig, we should be able to just like, wherever our malloc and free shit are, let's just do pub export function abs. And I don't actually know what type this is supposed to be. That's interesting. Man abs. int. In I32 val, I guess we'll call it. And we'll return abs val. Nobody in chat is making a joke about man abs? Come on, you guys. Come on. Why is this not working? All right, there we go. There we go. Twiggy. That's 4K, so not too bad, but I think that our BMP compression options kind of blow ass. Vacuum.bmp. Too busy being angry about GIF. Of course. So can we just like try like alpha RGB? That seems reasonable. A1 RGB. We could try this. What is X1 here? I don't know what that means, but QL code size might be pretty small, but I don't know if SCBI supports it. Yeah, I didn't see it there. This feels like that's, oh, we don't have the right, we don't have the bump. BIMP of 3.5K. Yeah, it's still pretty big. Okay. Maybe we should take a breather from this. I think it doesn't really matter. I think that we've probably learned that there's a good chance that it's just less expensive. Just less expensive, just hard code the data ourselves, which is pretty funny. I guess I'd be curious what a pick is. Can you expose an API for the chamber maybe? Oh, for like loading images? Might not be worth it. I know there are good Zig QI libs. Or is it QI or QL? I can't fucking tell. It's an I. Okay, I will probably take a look at this off stream because I like the idea. But for now, I think we're just gonna tank the cost of JPEGs or something, or BMP, if this works. We'll just tank the cost now because I don't want to get like too sidetracked on this. It's like it's gonna take too much time. So Let's just see if loading from vacuum BMP with our BMP version is fine, and if it is, I'll call it there for now. There's probably a way to make it work okay, without making too heavy trade-offs, but it's still showing white in the background. I don't like that it's doing that because I feel like we should be able to support alpha here. Can we dolphin here? Like, oh, I guess with the background being white here, it's really hard to fucking tell. Can we open this with like color paint? Yeah, like it should know that it should know. So like, what the fuck is going on there? What the fuck is going on there? Did I not like full refresh or something stupid? Oopsies. Is it because like SCBI load from memory? Let's just double check the docs here. I'm under the impression that if I put num channels, load from desired channels, I'm under the impression that if I write 4 there, it is supposed to give me RGBA. Yeah, RGBA. BMP doesn't have a transparency as far as I know, but then how come it's showing one? Right, if I open this, it fucking knows. Right, so like, and I intentionally encoded this thing as 16-bit RGBA. When I exported this thing, I said, hey, could you go to A1 RGB5? Right, so it's using the 16 bits, 5 bits of blue, 5 bits of green, 5 bits of red, and 1 bit of alpha. And so I just don't really understand why it's not getting that. It's possible that like the implementation of STBI doesn't handle that correctly. That's like very possible. We could try upping the bit depth here to 32-bit, tank the space cost initially just to see if this works. It's also possible that our texturing logic is just like fucking stupid. Like we could just be making a mistake. So yeah, see, this changing that didn't change the results here. I also want to make it bigger because it's kind of fucking silly for us to be like zooming in like that. So let's go to index zig and change our rectangle to go from like, width 5.5 or something. Like fuck it, Look at that fat boy. I mean, we could also, in this scenario, we could just say that white is transparent, but it's bothering me that I'm not getting it. So I'm curious to see, maybe in the texture, let's const val is equal to this. And then can we say like stud graphics print val is, can we print it as hex with an X here? Is this how this works? I can't remember. And then return val. So maybe the order is inverted. Because I am seeing low alpha sections. What was wrong, GIF again? GIF support, don't support. GIF support transparency, as far as I know. I mean, in that case, then it's probably just we made a mistake. Because I thought that they didn't support transparency. But, I mean, here we're definitely seeing values that should be low alpha. And so I just assumed that it was the GIF's fault, alternating. But I think I do not believe that anymore. Now my question is why the fuck are we seeing white here? Oh, because it's not blending it with the existing canvas. Yeah, it's just overwriting the pixel value. So the canvas behind our canvas is still fucking white. We can fix this. In index.js, if we set this to fucking blue, oh, it is blue. Never mind. I was so excited for a second. I was so excited. It felt so correct. How are you getting anything other than 0 or FF alpha? Oh, because I re-exported just now as 32-bit. But you are right. Let's try looking at can we set it back to RGB? We'll set it back to the 16-bit version, and we will look at the values again. And this is probably like fucking freaking out because it's printing like a million values. And yeah, so now we are seeing some values of 0, some values of FF0000. So it does look like it's also getting like the bit order correct as far as I can tell. Right, like I think that these sections where we're seeing FFFFFF and then one column of 0 is probably this row, these rows here, which kind of means that like the first things are probably the things that we're most interested in. And we are seeing like 0 for like 27 9 pixels in a row. So I'm missing some really obvious thing about why the alpha blending is resulting in white. It could be, honestly, it could be that it's something about like using this like put image call to copy paste the data onto canvas. I wonder if we change the background color of the entire body, if that could cause some problems. How do I style like the whole background of a page? HTML change body color. Is it background? Background color. Thank you. Thank you. Ah, ha ha, ha ha. It makes so much sense. It makes so much sense now. Okay, so it was working the whole fucking time. It's just that the canvas, we're punching a hole in the canvas to the fucking background, and I thought that we would be blending with what was already in the canvas, which is fucking stupid. Of course not. The issue is that it's too transparent. Exactly. I'd be curious now to go back to like the GIF version actually now, because I bet that because that was like the smallest thing we saw. And see if it still does the same shit. Sure, sir, there's a hole in your canvas. Yeah, sorry. I didn't know. So here we can go back to here and try to write background color blue. Yeah, okay. I'll take it. So that's not too bad. I'll allow it. Probably there's ways to get the size of this GIF down a little bit too, right? Like we did like vacuum GIF. Actually, there aren't really too many options here, huh? But okay, that's fine by me. Fine by me. Okay, so we just have to change this now so that we basically just want to multiply probably by the alpha here. So our texture, he gets an alpha back. Here. So const value of texture get x norm y norm. And we have to do something like canvas data is equal to canvas data at that value. And it's something like, so you have like something there already. Say you have like a full, fully red thing, right? We want to basically only adjust the RGB channels. We don't really care about alpha. And we want to adjust them. We want to like blend in our value. So if we have like, something that's like, 50% alpha, full blue, we probably want this to become like half blue, half red, which means that we like take the original color times 255 minus times 1 minus new alpha plus new times new alpha. That seems like what it would be. This needs to be in brackets. I believe it's something like out equals alpha times new plus 1 minus alpha times old. I think we just came to the same conclusion at the same time. Hell yeah. Hell yeah. Okay. Yeah, so we'll do that. We'll do that. We'll say, now can you do this with integer math? I'm not sure. You would do like 255 minus. Okay, so we'll say const new val is this. Const new alpha is equal to new val shifted right by 24. Okay, simple. Now we do 255 minus new alpha is old alpha. We take const old data is equal to this, right? And I guess we say const index is equal to this stuff, and then we have index like this. We take the. This has to be applied to all 3 channels, huh? Yeah, fuck it. We'll do it in float space. It's not great, but fuck it. So we'll do F32 is float from int. Const. We say that the old alpha divide equals 255.0. New alpha, we do the same thing. New alpha divide equals 255.0. Yup. Now we do. I guess we want like old color is the like sorry, my brain is just melting a little bit. I think that's actually probably fine to just do canvas data idx is equal to old alpha times old val plus new alpha times new val. And then just like ignore, then just like canvas data idx or equals 0xff00000. Like force it to be always alpha'd. I guess maybe it's up to the we could say this is up to the texturer to do this. We could give it the old pixel. I feel like I like that better because then we can kind of cheat however we want. In like a individual way. I like individual cheating, generic correctness. I'm happier to do that. So here we're gonna say here is the old pixel value. That feels better to me. So then we just do the blending in there. So it's kind of this shit all kind of goes in here now. And here we just say the new thing is a texturer. We still want that index calculation here. It's just a texture get x norm, y norm, and canvas data idx. So we can leverage that information if we feel like it. And now it's just about getting all this stuff right here. So this is, we have the value here. We have the alpha is this. And this feels fine. Yep. we don't need to do this index calculation. We just do everything here is old px here. So ret is this times old px. 255 minus alpha is wrong. Should be 1 minus. Yeah, you're right. You are right. Thank you. You're right. So this is old alpha times old pix plus alpha times val. And then we do the same thing here where we say, but we will unconditionally set the new alpha to full. That feels less cheaty. That feels less cheaty. He doesn't like that multiplication of old alpha and old pix. Yeah, that makes sense. That makes sense. Sorry, I was just trying to make sure that was correct. I think this is okay. I'm not like 100% sure on this, to be honest. But I'm like 30% sure. Which is enough for me. So we'll go back to var const ret is equal to is a u32 int from float of ret f. I think this is fine, but not 100%. But should do old alpha times go inside the thing. I'm not sure. Old alpha, no, because old alpha is already an F32, so it's fine. Zig build. Refresh. Okay, that's not good. Background, color, blue. This is just not doing, so what the fuck? How come this? Like, we should, like, if, no, even if this is wrong, this should never happen anymore, if my understanding is correct. Right, because we've just fucking set the fucking alpha unconditionally to 0xff. So how the fuck is it ever anything else? Unless I fucked up in graphics zig. No, we just like reassign the fucking thing. Am I fucking mental? Oh. Yes. Okay, that's very, very clearly incorrect. That's pretty funny. That's pretty funny. Okay. Can we just say, like... Why? Why is that? It could be this just, like, multiplication of casting this thing to an int is, like, totally fucking stupid. Could be. Could be. So I wonder, like, if it's, like... I would just to confirm to myself, because what I was thinking was 0x, like, so if I have like 10, right, or let's say I have like 99, right, and I want to divide this by 9, that becomes 1 1, right? And so my thought was that if I have 0x, you know, dd, and I divide that by 9, that will kind of contribute to these things in the same way. But maybe that's fucking stupid. I don't see why that's stupid, but it could be. So that's why I thought this cast to an F32 just multiplying by alpha and casting back would be okay. If that makes sense. I'd be kind of curious to see what happens if we just don't try to blend in the new thing. We just take the old alpha and we multiply by this. So that's kind of interesting. So we are parsing out the alpha correctly, right? We're seeing that, and it's just that this multiplication is definitely not blending the way I thought it would. So I guess maybe I'm stupid. Oh, we need to maybe and out the alpha, because that's probably like fucking things up a little bit. There we go. Nice. There we go. Okay. So we just have to like merge out. So this concept was correct, I guess, but it was just that the alpha the alpha was getting like merged into the other colors, which I guess makes sense. Does it? I think it does. I think that makes sense. I think it makes sense. I think that we were just like doing some addition there, so fucking stupid. So new alpha times as f32 float from int val and 0x00 ff. And now do we see a hey, there we go, there's a little vacuum. That took way fucking longer than I thought it would, to be honest. Like way longer. But I think that we got to explore a lot of fun concepts along the way. Like the idea of like embedding SCV image in here and like struggling with it. It was like, yeah, we got like alpha blending in. So I'm not like too upset, but it does mean that the actual part of the stream that I thought we were going to be doing, which was doing our textured Bezier curve, is taking a little bit of a back seat here. Okay. So we got this idea of like a texturer feels very good to me. I'm pretty happy with that. And so now the next thing to do is to try to like attach that same concept to our Bezier curves. So let me think about this for a second. Right now, our Bezier curve only draws like itself as a line, right? We go through this thing and we say, for a point along our Bezier curve, render a line. Now I'm trying to think, what does the rendering look like if we were instead trying to render a rectangle? Because a line is just a rectangle, right? Right, like when we are rendering, well, kind of. The way that our line rendering works right now is kind of silly. We kind of like come up like this, right? And we say, okay, I'm going to render x pixel 0, 1, 2, 3 on either side, essentially. Right, so we have like an odd number of pixels associated with this section of the line. And I wonder if we can kind of leverage that. So our Bezier curve is just made up of line segments, right? So if we have a Bezier curve like this, we're kind of rendering like one line, then another line, then another line, then another line, then another line, right? And yeah, what kind of sucks here? What sucks here is that we can still iterate by pixel this way, but the coordinate system of where we should be sampling from our texture is like not the same, right? We want to kind of render, we want to sample like in this direction, which I wonder if is doable, right? Because in the line segment, we should know like that this is 1.0 and that this is, you know, like 0.7 or something, right? We know like the time step values, we'll call them time step values, right? If we're t, we'll call it t. We know where in t we are, where t is like kind of like percentage of length into the Bezier curve. And so the x value should just be, like that's easy. The x value is easy. It is the distance in t that we are. But I take it back. It's not easy. I'm thinking again. Because how do we convert one of these pixels that we're walking into where along the line we are? Let me look at the line rendering code. We're looking. It's in graphics. He does, here we go. So he goes, Y center goes from like how far we are. What the fuck is this? X minus x star px times y distance. Oh, so this is doing like y equals mx plus b. That's what this is doing. And then he is iterating from IC, from negative to positive there. I don't feel like that's easy. I wonder if rendering a rotated rectangle before doing this makes more sense. Because then you could just render every line as a rotated rectangle, and then the sampling would become pretty fucking clear. Yeah, I like that idea better. Let's say that instead of doing whatever the fuck we said we were doing, let's say that this section is actually rotating rectangle. And so then if we can get that rotating rectangle correct, then the next step of texturing a Bezier curve should become way easier because you can just replace all this line rendering code with rectangle rendering code. Yeah, let's do that. Let's do that. Okay. So here's rotation. Here's rotation. Radians. And what is he gonna do with that rotation? We are going to have to draw a rectangle. And we've done this before. We've done this. When? Right? The idea of being like, I want to draw from here. So you have like a rectangle, right? And in order to render this thing, you kind of break this thing into like 3 segments, I think is what we did last time. And so then you can kind of like basically from these lines, you can calculate like the iteration order here. We did this in the QR code decoder for iterating pixels of a rotated rectangle. We can probably find that code somewhere. Rotated rect testing. Hell yeah, dude. All right. On Nightly, thanks for the prime. Appreciate it. So, some find rect corners shit. Types 2D. Here we made a pixel iterator for 4 corners. Okay. Find rect corners. Oh, so given a rectangle that was rotated, we ordered the corners by height, probably. So we did some trigonometry to figure out, based off of a center and a rotation, where the corners were in pixel space. I see. And then we have all the points, and we just kind of like sort them so that this that makes a lot of sense. So we kind of like we found them kind of like in order of their rotation: bottom left, bottom right, bottom left, top right. So that's like a clockwise rotation. And then we rotated this so that the smallest y value was on top. That makes a lot of sense. Then on each row we calculate the row bounds, blah blah blah. We figure out basically how to iterate from like here to here or here to here. And so all we have to do here, if we want to take this same fucking thing, we can like yoink this code, and the only piece that we're missing here is, given a specific pixel, where are we in XY in like texture space? So what does that look like? We would know where we are in pixel space, and we would also know the center of the thing in pixel space. We would know the center, the up direction. We would know both of those things. And so from there, we can probably figure out, by doing a little bit of linear algebra, basically like projecting. All we have to do is project the distance from our point to the center onto the like normal vector and adjacent, like the there's a word for this, I can't remember it. The normal vector. And we just project onto those 2 axes, and then we're chilling. Okay, we can try it. I suspect this is going to be a little bit difficult. But yeah, let's just start by yoinking that thing from before. So git diff. Where was this from? This is from binarization debug rotated rect test. Let's just kind of yoinkies this guy and try to bring him into our current project and just see what happens. So what was this thing doing? His main function was writing this rotated rectangle to a BMP through some BMP writer. We don't have a BMP writer here or libqr. What is libqr code used for? He's just used for the rectangle definition and the point definition. Okay, so we can probably adapt this at least a little bit to say like graphics equal to import graphics and const rect equal to graphics rect. We don't have a point, but we do have a pause too. And now we can just start. Maybe like the simplest way to make this work is probably to just adapt our type to match this thing. I'm thinking. It feels like a big job, and so I'm trying to figure out how to break it down into a smaller job. You know? Probably it makes sense for us to try to get this pixel iterator compiling and running onto just the canvas directly. So we kind of like yoinky, like get rid of this shit. Who fucking needs main? I guess main was kind of serving as documentation on how we ran this thing before. Which is just calling pixeliter.init, so that's not that bad. We'll figure that out. What is the output of pixeliter in this thing? He outputs an output, which is a x and y in usize. Okay. So x and y probably here are the corners of the rectangle. And so I guess that this is kind of assuming that we're working in pixel space already. That looks to be like the assumption that of this guy. Which makes sense in the context that he was written in originally, which was the QR code decoder, because the QR code decoder was in like pixel space. Okay. But other than that, this isn't too bad. Okay. So let's start by basically trying to construct this guy. He's going to define his own rectangle for now. Because our rect is like kind of expecting normalized space, and this guy's expecting pixel space. So it's not trivial. But yeah, we'll define a rect here in pixel space. And then we'll just have to figure out how to implement these APIs on it. So let's go to index Zig, who's already open. So let's close this. No? Other window? No? Okay. Oh, probably from Twiggy. There we go, okay. So sorry, thinking. I guess we'll just kind of maybe try to if true return at the top of this thing. Yep. And then before that, we're going to try to import this pixel editor. So const, what was our other file called? Rotated rect test. Rotated is equal to rotated import of rotated rect test. Okay. And his whole thing is we're just going to instantiate the pixel editor. We're going to use the center. Center is a graphics, pause 2. Yep. And a width is going to be in pixel space, and height is going to be in pixel space. And this actually has to be in pixel space too, so we actually need our own pause 2 here probably. Which is kind of annoying, but it's fine. So this is going to be x usize, y usize. We will fix this later, but I just want to get something working, you know? And I guess we would call this point, not pos2, to match the previous definition. All right, so now we should be able to say like rotated dot pixel iter with init and next. Okay. So we initialize this with rect. So we're going to say const rotated rect, which means that this guy is certainly going to have an angle. Is going to be a rect. We're just going to say the center is equal to we're going to put it at the center of our thing. So it's 150, 150 because our canvas is 300 by 300. We're going to give him a width of, 100, which should give you like most of the screen, but not too much. Height and angle is 0. We're just going to start with no rotation just to try to get something that compiles and runs, and then we'll come back to, more. All we have to do here is we have to go make a pixel iter from the rotated rect. And all we did was said, while it next, we try to say canvas memory at p dot y. What is this output? Yeah, p dot y times canvas width plus p dot x is equal to 0xff0000000. Okay. Okay. So certainly this won't compile. Type is not a function, right? So pixel iter needs an init. And then a bunch of stuff is not working. So these corners, he's expecting floating point values even though it's in pixel space, which is interesting. But I think that it's because when we were working with our rectangles in the QR code decoder, there were like sub-pixel things to think about. So we'll just kind of make them F32s for now. No CX and rotate rect. This is easy. Function CX returns AF32. It takes itself. And all he has to do is return center.x. Right does not exist. Oh, so we probably stored the rectangles as like top left, bottom right or something, and a rotation? That doesn't make any sense to me. That does not make any sense to me. Let's go look and see what they were doing. What we did in the past. So this is probably type CD. We had rect, top, bottom, left, right, and rotation. So probably we had the top and bottom stored like kind of like we probably started with a rectangle that was like axis aligned that had like top, bottom, left, right, and then we rotated around the center given that definition. So I'm trying to avoid making too many changes at once, but it does feel like right would be this would have to be center x plus width over 2. It would have to be. And for now, I'm just going to store everything as F32s for now because I think it makes it easier. No field named right. So right now has to be a function. Or, yeah, like this. No debug prints allowed. And this has to be returned, of course. Bottom, we need to do the same shit. Okay. No field name bottom, so we have to call it as a function, right? CY needs the same treatment. Okay. Okay. And rotation deg Okay. Fine. Fine. If that's what you want, that's what we'll give you. Rotation, deg, 0. Okay, he's mad about a debug print in here. Get the fuck out of here. Get those the fuck out of there. Oh, it already compiles. I wonder how fucked it is. I wonder how fucked. Because I feel like it shouldn't work. Because it just feels wrong. Oh. That's interesting. So it definitely doesn't work. What is this giving me? What the fuck? So here we sort such that the smallest y is on top, or is like the first element, I think. We're rotating so that the smallest element is first. Okay, that makes sense to me. Now when we iterate by pixel, we look at the row bounds for our current row. Okay. And well, okay, let's start by looking at the corners. Let's do that. So we'll say we'll import graphics here so we have something to print with. And can we just like graphics? I spelled graphics wrong. That's gonna be fucking annoying. Print, and let's just print out the return. So we'll call this like border points. Okay. So we refresh, we get the console, and our border points are x1, y9. Oh, e2. So this is 100, 100 essentially. 100, 200, 200, 200, and 200, 100. Okay, what happens if we rotate it a little bit? I'm curious about like a slight rotation. Slight rotation. Maybe not even a slight rotation. What if we just fucking rotate by 45 degrees? 45-degree rotation. So here we have 150, 75, or 79, 79, 150, 150, 220, and 220, 150. Okay. Okay, so that's starting at the smallest y, moving up to 1.5 E2. So 7.9, 1.5 E2. So this is 79, 1.5. Shouldn't I have... Oh, I do have two y values at the same. Okay. I guess let's just try to see... Now that we like at least can see something in there, let's try to figure out what the fuck it's trying to do when it iterates by pixels. Because what this did in our... Here, we'll see if we can pull it up. Let's see if we can pull it up. No, fuck off. Shut the fuck up. Oh my god, that was loud. Oh my lord. Who's here? Buddy? Come back. Right, like what we ended up with was... In fact... Oh, shut the fuck up. Why am I watching an ad on my own video? Yeah, at the end we did have the ability to draw a rotated rectangle. That is exactly what we ended up with, so... Right, we had it like here. Look at that guy. It's pretty. It's beautiful. It's wonderful. It is wonderful. Okay. So here the assumption is the left slope and the right slope. So I guess that's like if we're drawing our thing like this should be left slope and this should be right slope. So he is subtracting the third thing, this one, from the 0th thing. That makes sense. So let's just double check that that lines up with our understanding here. So here we have... Dude, this is so hard. It's so hard. So here we have x 1.5, y 0.7. So this is kind of like, we'll call that here. Then we have the next thing, x 75. So that's left. Y 1.5. Then we have x 1.5, y 2. And then we have y, we have x2, y 1.5. So this is actually rotating this way, which I think is wrong. This is saying that the right slope is y, the first thing. So this is what we have right now. This is left slope is 3 minus 0 over 3 minus 0. Yeah, okay. Then the right slope is 1 minus 0? Or 1 minus 0? So 1 and 3 are flipped. Unless this is fucking stupid. But it could be that this should be right slope and this should be left slope. I wonder what just happens if we do like a corners stood mem swap corners 1 and corners 3. It does feel like those are backwards based off these two names, and the fact that the thing that we're getting is like fucking stupid, so I'm willing to just fucking run it and see what happens. Oh yeah, okay, sick. So something about our coordinate space was backwards compared to what they expected. Let's try rotating this thing a little bit. So first of all, let's change the y height to, let's try like make sure our x and y don't match each other. So let's do a 30-degree rotation. Okay, so it's like rotating. Sorry, let's do like 10. So it looks like it's rotating clockwise, which is confusing. I would have expected counterclockwise. And if we set the y to be a little bigger, so we'll set x to be, 50 here. Oops, that's the position. I'm a dumbass. Okay, sure. So this rotation is going clockwise for whatever fucking reason. But we do have something, which is a big win for us. A big win for us. Okay. So I would like to understand why we had to swap those things. We should also start trying to adapt this to work in normalized space. Just 1 second. I need to look at something to see how much time I have here, because I don't know if I'm like short on time right now or not. 1 sec. 1 sec. Sorry. 1 sec. I just have to know if I have more time now. I have a little, yeah. Okay. So how do I want to handle this? I guess it's possible that my bottom here is backwards. Because in pixel space, bottom is higher. So that's probably where we fucked up here and had to do that swap. So probably I fixed bottom and then took that swap away. That does still work as expected. So that's good for us. That is good for us. Now, I would also like to understand why rotation degrees is rotating us clockwise. That's surprising to me. That is very surprising to me. So here, rect rotation radians is The rotation degrees times pi. Okay, so we get the rotation. How do we apply it? Top right rotation is the rect rotation, blah, blah, blah. Top right goes from the center plus corner distance times cosine sine. Oh, okay. Sure. Oh. Yeah, okay, I think I get it. I think I get it. There's something about like which way you're viewing the rotation from. Am I expecting the corners to rotate to the left or the world to rotate left around the box? There's something about that. It makes sense. Okay. Now, what we should try to do here is try to convert this stuff to just work in normalized coordinates. Fuck these. Well, is that what we want? Let me think about it. We kind of want these corners in pixel space because we do want to iterate through pixel space, which is what it's doing here. Instead of trying to fix this at all, let's kind of leave. Sorry, I'm just trying to think just a little more. I wonder if it makes sense to call this like a pixel rect, just to like reduce complexity in moving things over. And maybe we like convert our like real rectangle to this thing. Yeah, that feels like it'll get us somewhere. That'll get us somewhere. So here we're gonna say we have this rotated rectangle, and we'll call this pixel rotated rectangle. Right? And we'll have like an actual rotated rectangle, normalized rotated rectangle is going to be graphics rectangle for now. And this is center width height rotation. Okay, so center is equal to x 0.5, y 0.5, width 0.1, height 0.2, and rotation, we're gonna still keep this in radians because I feel like that makes more sense to me right now. We'll call this stood math pi over 4. Okay, so now what we need to do is we need to change this API so that it takes in our graphics rectangle. And maybe it like gives us, we here just convert that thing. So this is going to take in a graphics rect. And we're going to turn this into our const rect. This is norm rect and pixel rect. We just have to do some conversions. Okay, so this is going to be like the x center is equal to x is equal to, we're going to have to take in like a canvas width and a canvas height. Okay. And then we are going to have to do the conversions. We have graphics. Zig, we have 2x px. So this will take in a canvas. Nice. Which is a graphics canvas, which allows us to call canvas 2x pix, and these have to be public, I guess, which I think are fine. So this is going to come from the norm rect center x. Boom. Boom. Okay, we have the width is going to be the norm rect width converted to pixels as well. The names here are a little odd, but it's okay. And the rotation degrees is just going to be stood math radians degrees of norm rect rotation. So now everything else should just still keep working if we pass in the canvas here. which means that we need to, I think we call it graphics canvas. We did. So we'll just kind of move this thing all the way up here. And we pass it in here. So everything should still fuck. It's because everything should still work. Just kidding. So this, we just call this rect, like this. And then he doesn't like the math.pi/4. So that's in index wasm. Nope, index zig. That's confusing to me. As if I just write 4.0 here, does that kind of fix it? Yes. Okay, and then in 112 in our rotated rect test, he doesn't like these two xpx's of x norm rect center x, really? Oh, because these return I64s. I see. So we just float from int these. Got it. Got it. We will approach a more reasonable solution as we go, but we don't want to get too crazy, you know? Okay. There, now he's chilling. We refresh, and we still do have this rotated rectangle, and we're chilling. Okay. So now we have to figure out how to sample from this space. And so this pixel iterator is going to have to give us an output of the x and y in texture space. So he's going to give us a u and a v, we'll call it, to kind of match, gaming terms. Y, U, V, you use u and v for the texture coordinates, x and y for the world coordinates. And we just have to figure out how to make those things. So they're going to be something like, I wonder. U has got to be something related to the rotation, right? So okay. This is our x and y in UV space. So we'll call this u and v, right? So if we have some xy here relative to the center, we just have to do a dot product here on a u and v. So how do we do that? I think it's sine. So we have our rotation angle somewhere up here. And we can just say that our our u is going to be a pos 2. Technically a vec 2 is what we would usually want to use here, but that's okay. And this is just going to say x is cosine of the rotation degree, the rotation. Yes. This is coming together. Y is the sine of that thing. Okay. We are going to store the u vector in here. Yes. Okay, now here we can say v, the direction of v, the u is going to be self x, self y, dot producted onto self u. Yeah. That makes a lot of sense to me. Okay, so we're gonna say no, that's not right. Because this is in pixel space. So we need to do sorry, I'm thinking for a second. So we know our pixel distance from the center. Probably. We must have the center somewhere. Center pix is going to be, we'll call it a graphics pos 2. We can calculate our distance from that thing. So we'll call ourselves like const pos px is going to be a pos 2 of x is self x and y is self y. Simple. Simple. Const pos relative to the rectangle center is in pixel space should just be pos px sub self center. Right? Center px. And our center, our position normalized is just got to be like this divided by the width. I think. The width in pixel space. I think that makes sense. Maybe not. Let's try it out. So we have a rectangle, right? Jesus Christ. Okay, we have a rectangle. We're like here. So we have like this distance. I guess we kind of need to treat our x and y distances independently. Yeah. That makes sense to me. So we kind of like project this distance onto this direction, the u direction, and then scale according to the width of the box. Yes. That makes a lot of sense. That makes a lot of sense. Yeah, that's it. So we subtract, we have our center, we have our position relative to the center. We need to dot product that, we're going to say const u px is going to be the pos relative to the center norm, dot product onto self.u. Yes. And here we're going to say like v dir. I guess we should call it u direction. That feels u norm, we'll call it. The normal vector for the u and the vector, and we can figure out the vector for v by just inverting x and y. So we'll say const v norm is equal to a graphics pos 2 with the coordinates inverted. So x is equal to self u norm dot y and y is u norm dot x. That makes sense. And so the vpx is this thing but dotted onto v norm. And now we just return that u is equal to u pix over width pix, and v is v pix over self height pix. Now this is going to be in the range of negative 0.5 to 0.5. So now we just have to add 0.5 to both these. Cool. So this is pos rel center norm is pos px. Am I stupid? What am I looking at here? Our position pixels is this. Pos rel center px is this. We don't want this at all. Yeah, it's like this. And now we just need to implement the dot product probably, because I don't think we have it in this project. Oh, there's also no field named u in Pixelator. Oh, it's u norm. My bad. No field named u in struct, so this is 138. And we're missing field width px. So this is just going to be rect width yzig, because I like it. Center pex is rect center. Okay, sure. Rect center. This is gonna be pause to fucking conversions, but we'll live. We'll live. What about Zig? Do you like? Hold on a second. My brain hurts a little. What about Zig? It's low level, gives me control, fast, and like fast for development. Ease of use is great. It feels like simple, right? It's like C, but not so frustrating in a lot of ways. It's got a lot of like upgrades over C, but it's not as frustrating to use as something like it like lets the shackles off compared to something like Rust. You know? So you can kind of move quick. You have a little bit less of the guardrails, but it feels good to write. It's just fun. It's hard to. I don't really want to explain too much right now because I'm tight on time and I want you to implement this texturing thing. Okay, so we should be able to pull our dot product implementation from somewhere because can't be asked to look it up right now. I think it's just like 1 times the other or something. Physics. Hello. Physics sig. Dot. There we go. Yep. ax times ax bx ay by. Oops. I actually should have fucking pasted it into the other buffer. Dot. It's multiplies of the x's plus multiplies of the y's. Got it. Got it. Okay, so pause 2. There we go, pub function dot, and we're gonna take in pause 2s here instead, boom. Which should mean that this should compile if I did everything right. Build, exe. Not quite. No field name height pick, so we need to store that as well. So that goes in this pixel iterator. We have height, px is an F32 as well, and that just goes right next to width px. Great. Cool. And let's see now, I guess we won't have any evidence that anything is happening here, but now what we can do is we can try to color according to the UV coordinates. So we can try to see what happens if we go into our index zig, and before we were just writing out black, we should be able to write out something like plus, we'll call it const r is a u32 is equal to u value times 255.0. And then the g value is the same, but for the v coordinate, and shifted left by g shifted left by 8. And then we should be able to just say that we want this to be this plus r plus g. Oopsies, wrong window. Okay, promising. The green looks right. The red does not look right. So we fucked the u coordinate up in some way, shape, or form. But the fact that we're seeing like some sort of consistency along the axis of the rectangle is like very promising. Very, very promising. So we just gotta figure out what the fuck we did wrong with the u coordinate. So we took the u pixel is the position rel center dot onto the u norm. I guess we'll just like log this. Should have used or instead of plus. I think they're effectively the same here, but I'll take it. Yeah, I think it's effectively the same thing because they're both like within the bounds of the values that they're supposed to represent. You know what I mean? So there's like the only reason that the or is better is if there's like some form of overflow, I think. It would be maybe nice to look at the value of u and v here just to see like if they're like valid. U is a number and V is a number. And we'll look P.U and P.V. Not so deep graphics print. So we're in the fucking browser. Refresh. Okay. So we are seeing seeing them stuck at 0.5 to 1.0. Which is surprising to me, to be honest. There's something about the math there that is not lining up. And then there's a negative U down here. Because I thought here, this math, I thought this should line up to hold on. Is it sin x plus cos x always 1? I thought it was, but might not be. I think I typed Wolfram off wrong. Like sin x plus cos x. I thought this was always 1. But it is not. So that's probably my problem. That is likely related. It's sin squared x plus cos squared x. Oh, I wrote plus here instead of times like a fucking dumbass. Ah. I see. So wherever the fuck we define our normal vectors here, we should just do a const cx equal to this. And this would be sx is sine here, and then we can do cx times cx and sx times sx. Cool. So that should give us more correct normal vectors. However, I'm still seeing an unexpected set of x value. It's just not doing what I expect still. Do I ever see U drop? I mean, I do see some pretty low U values in here. I'm seeing them drop down to like 0. Like 0.3, 0.2, 0.1. I expect that there will be areas eventually where it should get down to 0. Well, okay, what if we just, can we just, like, only draw the U value in our rendering code? Here, can we just, like, not do this? Oh? Okay, interesting. Interesting. Wait, is that correct? What is our width? Okay, let's not rotate this thing at all. Okay, that seems right to me. So the U actually looks correct. Maybe it's the V that's wrong and I was getting thrown off. Oh no, that looks right too. Hold on. Okay, so axis aligned, it's looking okay, actually. So let's try rotating it a little bit again and see if that's still fucked. Okay, wait, hold on. It doesn't feel like it's rotating. So here we have red in the bottom left corner. Hold on. Now it's red in the top right corner. Are we rotating in the fucking opposite direction by mistake? Oh, that's a very real possibility. I'm just going to like go out on a whim here and try inverting this cosine and sine thing just on a whim. Okay. So where am I supposed to be? It's like in index zig. Let's try a rotation now a little bit. Okay, that's working as well. Let's try a 45-degree rotation. No, that's still fucked. Still fucked. There's also a good chance that the projection onto the UV vectors are not correct. That's a very real possibility. Very real possibility. So let's look at rotate rect test. Like, is this just fucking stupid? So oops, I want color paint. If we have some rectangle, right? And he's like boom, 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 boom. And we say this is over here and this is over here. Both of these are 1.0. We are saying that if we have a point here, we calculate this distance and we project onto this. Boop. The maximum value that could be is 0.5. And the minimum value could be 0. So this is just a fucking stupid calculation. Because 0 to 0, no, it couldn't be. Because if it's over here, this could be negative 0.5 as well. Yeah. No, sorry. If I just project this onto a 1.0 vector, this could be negative 1. Okay, so we have negative 1 to 1. Negative 1 to 1. That we divide by the width. That's wrong. It should be this over 2. We want to divide by half the width and add 0.5. Maybe. I think. There's a chance. It's kind of the other way around. That looks even more fucking stupid. I feel like I'm missing something really obvious. Something really obvious and it's just not clicking. So this is 1.0. Let's say that the width of the whole rectangle is 200, right? Let's say that this distance is like, this distance is going to be like maybe like 150. Projected onto here should end up at like 100, right? That's what you get here. So if we're trying to say that we want this to map to 1.0, this 100 to map to 1.0, we should take the value of UPX, divide it, divide it by the width, so that'll give me 0.5, and then add 0.5. Because if it was over here, right, this would be 150 still, but this would become negative 100 because this is negative 1.0. This divided by 200 becomes negative 0.5. When we add 0.5, it gets 0. So I don't get it. I do not get it. Wouldn't be using the equivalent of barycentric coordinates of rectangles work for UV work? Barycentric coordinates. The location of a point is specified by reference to a simplex triangle. I don't know. I feel like conceptually what I'm saying, like I feel like it should work. I just don't understand. I'm just missing some obvious little thing, is how I feel. That's how I feel. And the fact that it works when we're upright. So when rotation is 0. Oh, that's not working. Whoa. That doesn't look right anymore, actually. It's too bright. Did I forget to undo some math there that I fucked up? What the fuck? index zig. In index.zig, we are coloring this thing according to something. G and R. Okay, let's only look at R. I feel like that makes sense for now. We'll only worry about one axis. So with no rotation, I want to double check here. We should be seeing U values kind of like monotonically increase, which we're not really seeing, surprisingly. Which means that these calculations look kind of suspect, to be honest. So if y is supposed to be orthogonal to u norm, either the x or y point needs to be negated. That's a really good point. That's a pretty good point. Although I don't think that's the problem. It could be. Because right now, like, even without the v thing, we're still... Oh, wait, there we go. That looks... Okay, so u going from 0 to max. Okay. I don't know why it didn't look like that was happening a second ago. Maybe we were kind of like a little behind. Let's try rotating this a little bit by like let's say stood math pi, right? So if we do a full half rotation, the coordinate system should flip the other way. But it's just not moving. It's just not moving, which means that like this like UV stuff must be just like undoing rotation, which just doesn't make any fucking sense to me. It just doesn't make any fucking sense to me. Right, that does look like what's happening, right? Is that like the rotation is having zero effect. What if we like rotate by half a rotation, like a 90 degree? Oh yeah, that's what. Isn't pi just a full 360 degree rotation? Pi should be a half rotation. So like the fact that here we're going left to right and here we're going left to right is like a big mistake. Massive mistake. Which kind of indicates that like we're not handling the like signedness of this correctly. Maybe go a bit slower and try to solve for line intersection and then normalize. Line intersection and just normalize. Don't think I understand. Don't think I understand. We're idiots. We're idiots. We're idiots. We're idiots. We're idiots. We're idiots. Fuck. Sine of cx times this. We are losing the negative when we multiply by itself. Okay. So now, rotation stood math pi. That's good. Okay, that's good. Let's do a like pi over 2.0. Also looking good. Pi over 4. Not good. Not good, not good, not good. In fact, what we're seeing seems to be some sort of like fucky-wucky wrapping. Oh. I mean, because we're just being stupid. We do want x and y to be cx and sx, but we need to normalize. We were trying to normalize by doing squared. Which was silly. Which was silly. Instead, we should be normalizing by saying, u... const len is equal to cx times cx plus xx times sx. And this should be over len? No, wait. Square root of this. But this is 1. You don't need to normalize cx squared is always 1. Yeah, so this, yeah, you're right, you're right. So I was kind of in the right frame of mind there before. So maybe I just kind of like psyched myself out about that. That's possible. That's possible. Let's add green back. I think I just psyched myself out. There we go. That makes way more fucking sense. So I just kind of psyched myself out with like Pythagoras earlier. And that fucked me. Because yeah, now it looks like it's kind of following. We can do like math.pi over 2 times 3 or something. Yeah, that looks pretty fucking reasonable. I'm just a dumbass. Yeah, that feels pretty good. It's not perfectly aligned. I can see some red leaking in around the corners. But that's good enough for me. That's good enough for me for now. So, that was a bit of a pain. Apologies for the confusion there. Sometimes you just don't get it. But I think we made pretty good progress today. So we got the ability to draw an arbitrary texture on a rectangle for the vacuum. We imported a PNG, we imported a GIF. We kind of like found ways to like embed STBI image into our wasm modules. As well as like kind of profiled some of like the different like sizes of the different decoders and stuff. So that went pretty well. Then we like had some trouble with like alpha, and we kind of figured that out as well, where we did like alpha blending of the vacuum and stuff. And then we got this like rotated rect texturing. So we're in a pretty good spot now to be able to once we can go from here to like Bezier curve, I think pretty reasonably easily. I think there's gonna I'm gonna have to do some cleanup on this code. This code kind of sucks ass because I kind of like was like merging 2 projects. So I'll do some cleanup there. But overall, pretty good. Yeah. So thanks for watching, guys. If you like what you saw, we stream most days around like 12:30 Pacific time, 4 to 4 Pacific time. The first like hour and a half or so is usually like kind of like hanging out and doing some like cleanup code. The second 2 to 4 is usually doing like whatever you see on YouTube, like kind of more focused work. There's a YouTube link in the Twitch description if you want to check that out. There is a GitHub link in the Twitch description as well if you want to check that out. A Discord link, Patreon link. Don't forget that spheriphoria.dev is live now, so if you want to try contributing a wasm chamber, there's like a list of things that you can do under upload and how to like, tutorial on like how to make one and stuff, so you can check that out if you want to try. Otherwise, thanks for watching, guys, and let's say goodbye to YouTube and Twitch. Let's find someone to raid.